Okay, so this is part 3 of the videos for this week, and in part 2 we talked about transformations of trig graphs, and that was notes number 41, and so we're going to continue with notes 41, and we're going to continue looking at transformations of trig graphs, but for this part of the lesson we're not actually graphing anything, so maybe that's a relief. We're just going to talk about the transformations. So let's take a look at number 9. Okay, it says describe the transformations that would change y equals sine of x to y equals 4 sine of x plus 2, and state the new period and amplitude. So what happens to a graph if you multiply it by 4? That would be a vertical stretch, excuse me, a vertical stretch by a factor of 4, which means it's 4 times taller. Okay? What would happen to a graph, any kind of graph, if you add 2? So that is going to shift it up. So that's a vertical shift up 2 units. Okay. Now remember, the period is the width of one cycle. Does shifting anything up change its width? No. Does stretching it vertically change its width? No. So the period remains as it originally was, and the original period of a sine graph is 2 pi. So the period is still 2 pi. How about the amplitude? Does shifting something up change its amplitude? The amplitude is the distance from the center to the top. Does shifting the whole thing change that? No. Does stretching it change that? Yes. The vertical stretch will change the amplitude. So the amplitude was originally 1, from the center to the top was 1. We just made it 4 times bigger. So the new amplitude is 4. Okay, problem number 10. Describe the transformations that would change y equals cosine x to y equals negative 1/3 cosine of 5x. State the new period and amplitude. Okay, anytime you multiply a function by a negative, that's going to be a reflection across the x-axis. Then notice that we have the 1/3 here. We're multiplying the function by 1/3, just like in number 9, we multiplied the function by 4. Multiplying by 4 made it 4 times taller. Multiplying by 1/3 is going to make it 3 times shorter. So that's going to be a vertical shrink. It's going to be 1/3 as tall as it used to be. So we say it's a vertical shrink by a factor of 3. And then how about the 5 in there? Instead of x, we have 5x. So what's that going to do? Remember from the last part of the lesson that if you multiply inside the function, you're going to horizontally stretch or shrink it. And remember how I gave you the way to think about it as a roller coaster? And you see right now this roller coaster is 5 times the fun. Cosine of 5x is 5 times the fun. What does 5 times the fun mean? That means you're going to have a whole lot more of these little curves all squished together. You get to go up and down a whole bunch more times. So that means we have a horizontal shrink. It's going to be narrower than it used to be. Horizontal shrink by a factor of 5. 5 times narrower. Okay, so now let's take a look at the period and the amplitude. Remember, the period is the width of a cycle. Shrinking it horizontally is going to change the width of the cycle. So we're making 5 times as many curves in the same amount of space. So that means the period is going to be what it originally was, 2 pi, divided by 5. 5 times as many of those curves are happening. And how about the amplitude? Because of the vertical shrink, now the graph is only going up as third as high as it used to. So instead of having an amplitude of 1 from the center to the top, it's going to have an amplitude of 1/3 from the center to the top. You don't pay attention to the negative sign when you're figuring out the amplitude. You just want the absolute value of the number in the front of the equation. Okay, next one. Number 11. Describe the transformations that would change y equals tangent of x to y equals -6 tangent of 0.5x. State the new period and amplitude. Okay, so because of the negative, just like we saw in the last problem, there's going to be a reflection across the x-axis. Now, it wouldn't be a bad idea for you to pause the video, think about it yourself, and then resume and see what I say, just so you can test your understanding. What's the 6 going to do? Because of the 6, that's a vertical stretch. It's going to be 6 times taller than it was before. Vertical stretch by a factor of 6. Six times taller. What's the 0.5 going to do? Okay, think of that as 1/2. So this tangent graph is half the fun. What does that mean? That means it's going to be wider. So that would be a horizontal stretch. So you can say by a factor of 2, that means it's 2 times as wide. Okay, so let's figure out the period and the amplitude. The original tangent graph had a period of 2 pi. Period of y equals tangent x. Did I say 2 pi? If I did, it was wrong. I mean 1 pi. I don't know what I said a minute ago. The original tangent graph has a period of 1 pi. Now, we've just stretched it twice as wide. So the width of the cycle is now twice what it used to be. So the new period is 2 pi. What about the amplitude? The amplitude is the distance from the center to the top. And the amplitude for tangent was already undefined. If you multiply that by 6, it's still going to be undefined. Okay, number 12. Describe the transformations that would change y equals secant x to y equals -secant x minus 12. State the new period and amplitude. Okay, you should probably pause and think about this for yourself. The negative in front is going to do the same thing that the other negatives in front did, reflect across the x-axis. Notice we're not multiplying by any other thing. There's no vertical stretch or shrink. We're not multiplying inside the function by anything, so there's no horizontal stretch or shrink. We are subtracting 12, so that would be a vertical shift down 12. Okay, the new period and the new amplitude. The old period for secant was 2 pi. Did we stretch or shrink it horizontally? We did not. So we did not change the width at all. So the new period is the same as the old period, 2 pi. How about the amplitude? The amplitude of a secant graph was already undefined. Do whatever you want to it. Don't change it, whatever. The amplitude is still going to be undefined. Okay. We just have 2 more. And I've switched it up on this one. It says write the function you would obtain from taking y equals sine of x and stretching it vertically by a factor of 10 and stretching it horizontally by a factor of 3. Okay, do you want to give it a try? Pause, give it a try, and then you can check your answer. So, the vertical stretch means we're going to multiply the outside of the function by 10. So we have a 10 before the sign. The horizontal stretch means it's not going to be as much fun. This roller coaster is not 3 times the fun. It was stretched out. It's 1/3 the fun. So you're going to have a 1/3 inside the function. Okay, so vertical stretch outside, horizontal stretch inside. And number 14. Write the function you would obtain from taking y equals cosine x and shifting it vertically down 3, reflecting it across the x-axis and shrinking it horizontally by a factor of 2. Okay, you can pause and give that a try. All right, shifting it down 3, that's where we're going to subtract 3 on the outside. I'm going to have a minus 3 out there. And then reflecting it across the x-axis, that's going to give us a negative on the outside. And then shrinking it horizontally, that's going to make it more narrow. That's going to make it more fun. So this one is going to be 2 times the fun. So we're going to have 2x in there. Remember, the roller coaster is 2 times the fun if you make it 2 times narrower because you get more ups and downs. Okay. Now, here's what I'm suggesting for you. I think I've given you about as much as I can for this week according to our time constraints. So I'm not giving you a new textbook assignment or any kind of assignment that's required. You have the assignment from part 2 where you had some graphs to do and some amplitudes and periods to list. So if you have time and you want some extra optional supplemental work, we could all definitely use the practice. So you can choose to do problems from your textbook. I've given you some pages and some problems to select from. And then I've also posted those pages on Google Classroom and the answers to the answers from the book in case you don't have a book. So there you go. Thanks a lot.